So I've been picking up a whole bunch of these motion sensitive night lights, and performance has been, let's just say, it's not been great, and the battery life definitely isn't the advertised only charge 4 times a year. But I thought it might be interesting to try and hack one of these and see if we can improve it. I do have a whole bunch of these nice radar motion sensors. The what are these? The RCWL0516. But let's crack open one of these and see what's inside. I've got round ones and I've got oval ones, so pretty interesting. So the tops just kind of pop off. So if you just give it a bit of a squeeze, then we're in. So we have the motion sensor. There is a mystery chip. It's a 8-pin mystery chip. They've removed any identifying marks. There is a light sensitive resistor here, and here's some charging circuitry. Let's pop this screw out and see what's underneath. Okay, circuit board just comes out, and we have a massive 350 milliamp hour battery. It's tiny. There's the actual PIR sensor there. Let's take a photo of this, and then we'll do our best Big Clive impression and reverse engineer the circuit. So one moment, let me just get a photo. Now, as always, this video is sponsored by PCBWay. We've used them for a lot of PCBs now, and they've been great. There's a link in the description. So it's pretty simple. It's a single layer board. The positive side of the LEDs are all connected to the battery plus, and then the negative side of the LEDs are switched by our mystery chip down to battery minus. Now, that's all there is to say about that bit of the circuitry. There's no apparent current limiting circuitry, so at least I can't see any. So here's our mystery chip. We have the PIR sensor, and the positive and the negative side of that PIR sensor go straight into our chip. There is a light-dependent resistor with R5 as its resistor divider, and there's a C3 decoupling capacitor. Now, over on the charging side, we have a TP4054. There's a 3.3K programming resistor, so that gives us around 300 milliamps charging. And there's an LED to indicate that charging is happening, and again, we have a decoupling capacitor. So it's a pretty basic circuit, really, not much to talk about. So here's my reverse engineered schematic. So we have the charge controller IC with its programming resistor, 3.3K. Got the lithium cell, got the decoupling capacitor, and then we have our mystery chip. So here's the LDR with its potential divider feeding into the chip. The PIR sensor, PIR plus and PIR minus, go straight into this IC. And then we have the two switch pins that switch these LEDs on and off. So here's all the LEDs. They all get switched down to ground. So it's pretty simple, really, highly optimized in terms of BOM. So this mystery IC is obviously quite specialized for PIR sensors and switching LEDs. So that was pretty interesting. I am quite intrigued by the lack of any current limiting on the LEDs. So what I might do is hook this up to my bench supply and just see how much current is being drawn. We'll do the current limiting so we don't blow the LEDs up. But let's take a look. So we'll have to desolder the battery, so that should be fairly straightforward. Okay, so it's hooked up to my bench power supply. There we go. Managed to trigger it. So I've got my current limit set to 100 milliamps. It's currently drawing 68 milliamps. So there's definitely some built-in current limiting on this mystery chip. So anyway, let's have a play with some of these nice motion sensors. So we'll move this out of the way. And I've wired a pin header onto this. So now these can take a light dependent resistor as well. So somewhere in my bag of bits I have some light dependent resistors. Okay, got some light dependent resistors. Let's zoom out a bit. So these are pretty interesting, these light dependent resistors. So I'll stuck it in some breadboard here, and we have around 2.6K at the moment when it's in light, and if we cover it up, Yeah, it's gone up to 12 kilo ohms. So 2.5, 12. So what we can do is we can solder this light dependent resistor onto this board, but let's plug this in and have a play with it. We've got a flashing LED. Let's get a normal LED. Flashing's a bit silly. 1 second. Okay, there we go. Nice solid red LED. Now if we stay still, it's gone out. If I move, it goes on, goes out. Now it stays on for around 3 seconds. Now what you can do is on this board there is a space for a capacitor that you can solder on. Yeah, so on this side of the board, this space here, CTM, if we put a capacitor across there, it will increase the timeout. So let me grab a little capacitor and we'll see if we can increase the timeout, because 3 seconds is not really enough time to get to the toilet. So not ideal. So on, off, on, and then off. So yeah, so we'll need to have a bit more time on that. So let me get a capacitor and fix that.
Fingers hover, trigger ready. The feed.
Nighttime mode activated. Needs to be very dark. Let's just leave this to turn off, and then we'll try again and check the motion detection does actually work. Okay, so we should be... Oh, I moved and it came on. So that's working pretty well. It is very sensitive. Now apparently it is possible to solder a resistor on here and reduce the sensitivity, but we'll try this out and see how well it works. So here's the plan. Let's just zoom out of it. So I have a board here that I have stripped of everything. So I've removed the PIR sensor and the mystery chip and its supporting components. So what we're going to do is we're going to place this module somewhere around here, and then we'll have a current limiting resistor and a MOSFET driven from the output. So we'll probably put it around like this. We'll power it from the battery plus and minus, and fingers crossed, should work nicely. Let's try soldering it up. I will get the microscope out again.
Fingers hover, trigger ready. The feed don't stop. Algorithm plotting moves, trying to make me cop. Click here, click there. Whispers in my dome like a hustler on the block, selling data for a home. Scroll wars, pixels pop, battles in the streams. They pimp the ads out, chasing digital dreams. This ain't no safe zone, it's the wild, wild web. Got me dodging subscriptions like bullets to the head. Almost subscribed, but nah, they can't get me. They bait the hook, but my wallet stays gritty. They want my clicks, my soul, my pride. But I'm too slick, I almost subscribed. I almost subscribed. But I'm too slick, I almost subscribe. Cookies track my shadow, stalking through the night. Digital fingerprints, yeah, they searching for a bite. Every pop-up a trap, every link a snare. Selling my secrets cheaper than fresh streetwear. Tried to Netflix my hustle, Hulu my grind, but I stream my own life, no contract sign. Every ad a narc, every offer a scheme. I ain't selling my hustle for a buffering dream. Almost subscribe, but nah, they can't get me. They bait the hook, but my wallet stays gritty. They want my clicks, my soul, my pride. But I'm too slick, I almost subscribe. I almost subscribe. I almost subscribe. I almost subscribe. But I'm too slick, I almost subscribe. Almost subscribe. Almost subscribe. Almost subscribe. I almost subscribe. I almost subscribe. But I'm too slick, I almost subscribe. I almost subscribe. I almost subscribe. I almost subscribe, but I'm too slick. I almost subscribe.
So it's actually come out much better than I expected. The board seems to be working. I put on a much bigger battery, 820 milliamp hours. So let's see if it slides back into its case. So I'll put the battery in, and then this just needs to slot in so that we can charge it without any problem. So I think that's pretty good. Here's the screw hole, so let's put the screw back in. And then the lid. So let's put the diffuser back in. Just it looks like a normal one. I wonder if we can we do that? There we go. And then close the lid. Good as new. So we'll try this out later.
I've mastered the ability of standing so incredibly still that I've become invisible to the eye.